Good morning, students. In the last class, we discussed about the kinetic energy and potential energy, right? So today we are going to discuss conservative forces and non-conservative forces. Conservative forces and non-conservative forces, right? So start from the conservative forces. When we say that forces are conservative and when we say that the forces are non-conservative. So conserve means so before and after work done, that is the force remains, that is the force remains the same. So or work done remains the same. So that we call as the conservative forces, right? So start from the conservative forces. So when we say that the force is conserved, right? So if the amount of work done by or against the force is depends on initial and final positions and it is independent of path forward. So this is the condition for the conservative force, or we say this one as the definition for the conservative force, right? So now forces we observe we consider any one object, right? So which is placed on the surface, right? So here I am applying some force, that is the external force or applied force, right? So due to the external force, the object gets displaces, right? So it changes its position from initial position to the final position. That means change in its position. So position change ಆಗ್ತಿದೆ ಅಂದ್ರೆ that means the displacement, that is because of the external applied force. So as the force is applied and the object gets displaced, that means work is done. So work done ಆಗಬೇಕು ಅಂದ್ರೆ ನಮಗೆ ಕಂಡೀಷನ್ ಏನಿದೆ, ಫೋರ್ಸ್ ಇರಬೇಕು. ಸೊ ಆಬ್ಜೆಕ್ಟ್ ಏನಾಗಬೇಕು, ನಮಗೆ ಡಿಸ್ಪ್ಲೇಸ್ ಆಗಬೇಕು. ಸೊ ಇಲ್ಲಿ ಎರಡು ಕೇಸ್ ಇತ್ತು ಅಂದ್ರೆ ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, ವರ್ಕ್ ಡನ್ ಆಗಿದೆ. ಸೊ ದಿಸ್ ಈಸ್ ದ ವರ್ಕ್ ಡನ್ ಬೈ ದ ಫೋರ್ಸ್. ಸೊ ಇದನ್ನ ಏನಂತ ಕರೀತೀವಿ, ವರ್ಕ್ ಡನ್ by the force on this object, right? So next, work done against the force, right? So work done against the force is nothing but here the object which is placed on the surface, as the object starts to move, so there is a force which arises between the object and to the contact surface. So that force we call as the frictional force, right? So this is the force which is against the applied force, right? So that means friction kuda enagide, here we have the force but the object gets displaced, right? So ಇಲ್ಲಿ ನಮಗೆ ಫೋರ್ಸ್ ಇದೆ, ಜೊತೆಗೆ ಆಬ್ಜೆಕ್ಟ್ ಕೂಡ ಡಿಸ್ಪ್ಲೇಸ್ ಇದೆ, ಬಟ್ ಆಪೋಸಿಟ್ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಇದೆ. ಸೊ ಇಲ್ಲಿ ಕೂಡ ನಮಗೆ ಏನಾಗ್ತಿದೆ, ವರ್ಕ್ ಡನ್ ಆಗ್ತಿದೆ. ಸೊ ದಿಸ್ ಇಸ್ ದ ವರ್ಕ್ ಡನ್ ಡ್ಯೂ ಟು ದ ಫ್ರಿಕ್ಷನ್, ದಿಸ್ ಇಸ್ ದ ವರ್ಕ್ ಡನ್ ಡ್ಯೂ ಟು ದ ಅಪ್ಲೈಡ್ ಫೋರ್ಸ್. ಸೊ ಎರಡು ಕಡೆಗೂ ನಮಗೆ ವರ್ಕ್ ಡನ್ ಆಗ್ತಾ ಇದೆ, ಬಟ್ ಫೋರ್ಸಸ್ ಏನಿದೆ ನಮಗೆ ಡಿಫರೆಂಟ್ ಇದೆ. ಒನ್ ಇಸ್ ಬೈ ದ ಫೋರ್ಸ್ and another one is against the force. So against the force is the frictional force, right? So in the case alli ಏನು ಹೇಳ್ತಿದ್ದಾರೆ, it depends on, so this force, so ನಾವು ಯಾವುದನ್ನ ಕನ್ಸರ್ವೇಟಿವ್ ಅಂತ ಫೋರ್ಸ್ ಕರಿತೀವೋ ಆ ಫೋರ್ಸ್ ಯಾವುದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿರುತ್ತೆ. So that is purely depends on the position, that is initial position and final position, and it is independent of the path followed, right? So ನಮಗೆ path followed either it can move in a straight direction or it can move in a curvilinear position. So path ಏನಾಗಬಹುದು, ನಮಗೆ ಈ ತರ ಚೇಂಜ್ ಆಗಬಹುದು. ಸೊ ಇನ್ ದಿಸ್ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಾದ್ರೂ ಆಬ್ಜೆಕ್ಟ್ ಮೂವ್ ಆಗಬಹುದು, ಈ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಾದ್ರೂ ಆಬ್ಜೆಕ್ಟ್ ಮೂವ್ ಆಗಬಹುದು, ಅಥವಾ ಸ್ಟ್ರೈಟ್ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಾದ್ರೂ ಮೂವ್ ಆಗಬಹುದು. ಅದನ್ನೇ ಹೇಳ್ತಾ ಇರೋದು. ಸೊ ಅಂತ ಫೋರ್ಸ್ ನಾವು ಏನಂತ ಕರೀತೀವಿ, ಕನ್ಸರ್ವೇಟಿವ್ ಫೋರ್ಸ್. ಸೊ ಕನ್ಸರ್ವೇಟಿವ್ ಫೋರ್ಸ್ ಇಸ್, ಇಟ್ ಈಸ್ ದ ಅಮೌಂಟ್ ಆಫ್ ವರ್ಕ್ ಡನ್. ಸೊ ವರ್ಕ್ ಆಗ್ತಾ ಇದೆ, right? So amount of work done by the force or against the force. Against the force is nothing but the some frictional force or opposing force. ನಾವು ಅದನ್ನ ಯಾವುದನ್ನ ಬೇಕಾದ್ರೂ ಕನ್ಸಿಡರ್ ಮಾಡಬಹುದು. ಸೊ ಈ ಎಕ್ಸಾಂಪಲ್ ಗೆ ನಾನು ಫ್ರಿಕ್ಷನಲ್ ಫೋರ್ಸ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ದೀನಿ. ಅಗೇನ್ ಫ್ರಿಕ್ಷನ್ ಇಸ್ ಆಲ್ಸೋ ಎ ಫೋರ್ಸ್, ರೈಟ್? ಅಗೇನ್ಸ್ಟ್ ದ ಫೋರ್ಸ್ ಡಿಪೆಂಡ್ಸ್ ಆನ್, ಸೊ ಇಲ್ಲಿ ವರ್ಕ್ ಆಗ್ತಿರೋದು ಯಾವ್ದ್ರ ಮೇಲೆ ಕಂಪ್ಲೀಟ್ ಆಗಿ ಡಿಪೆಂಡ್ ಆಗಿರುತ್ತೆ ಅಂದ್ರೆ ಇನಿಷಿಯಲ್ ಪೊಸಿಷನ್ ಆಫ್ ದ ಆಬ್ಜೆಕ್ಟ್ ಅಂಡ್ ಫೈನಲ್ ಪೊಸಿಷನ್ ಆಫ್ ದ ಆಬ್ಜೆಕ್ಟ್. ಸೊ ಇದ್ರ ಮೇಲೆ ಮಾತ್ರ ಡಿಪೆಂಡ್ ಆಗಿರುತ್ತೆ ಅಂಡ್ ಇಟ್ ಈಸ್ ಇಂಡಿಪೆಂಡೆಂಟ್ ಆಫ್ ದ ಪಾತ್ ಫಾಲೋಡ್ ಬೈ ದ ಆಬ್ಜೆಕ್ಟ್. ಅದು ಯಾವ ಪಾತ್ ಬೇಕಿದ್ರೂ ಚೂಸ್ ಮಾಡ್ಕೋಬಹುದು, ರೈಟ್? ಸೊ ದಿಸ್ ಇಸ್ ದ ಡೆಫಿನೇಷನ್ ಫಾರ್ ದ ಕನ್ಸರ್ವೇಟಿವ್ force, right? So example for the conservative force: gravitational force and electrostatic force, right? So these are the two examples for the conservative force, right? So gravitational force kuda enirutte namage it is depends on the initial and final position of the object, right? So work agtide andre purely depends on the initial and final position of the object and it is independent of the path followed by the object. So gravitational force ಮತ್ತೆ electrostatic force. So electrostatic force ನಾವು second year ಅಲ್ಲಿ study ಮಾಡ್ತೀವಿ. So here in first year we are going to discuss about the gravitational force, right? So considering one example. So this is the surface or ground, right? Consider one object which is on the surface of the ground or surface of the earth having some mass m, right? So now I am applying the some force, that is the external force, to lift this object of mass m to the certain height h. So initially we taken this position is A and here we taken the position is B. So the distance between A and B is we taken that as height, that is h, right? So here I am applying the force, that is the external force. So work is done because it displaces from its initial position A to the final position B. So ಏನಾಗ್ತಿದೆ vertically height ಅಲ್ಲಿ displace ಆಗ್ತಿದೆ. So ನಾವು force ಕೂಡ apply ಮಾಡ್ತಿದ್ವಿ. So ಇಲ್ಲಿ ಏನಾಗ್ತಿದೆ ನಮಗೆ work done ಆಗ್ತಿದೆ, that is work done by the external force. So that work done by the external force is stored as the potential energy. We written that one as W is equals to mg h, where h is the height which it displaced, right? So force act ಆಗ್ತಿದೆ ಅಂದ್ರೆ ಲಿಫ್ಟ್ ಮಾಡ್ತಾ ಇದೀನಿ ಇದೊಂದು ಆಬ್ಜೆಕ್ಟ್ ನ. ಸೊ ಅಪ್ ಟು ದ ಸರ್ಟನ್ ಹೈಟ್ ವರೆಗೂ ನಾನು ಲಿಫ್ಟ್ ಮಾಡ್ತಾ ಇದೀನಿ. ಸೊ ಲಿಫ್ಟ್ ಆಗ್ತಿದೆ ಅಂದ್ರೆ ಏನಾಗಿದೆ, ಇಟ್ ಈಸ್ ಡಿಸ್ಪ್ಲೇಸ್ಡ್. ಸೊ ಡಿಸ್ಪ್ಲೇಸ್ ಆಗಿದೆ ಅಂದ್ರೆ ಫೋರ್ಸ್ ಇದೆ, ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಇದೆ. ಸೊ ಅಲ್ಲಿಗೆ ಏನಾಗುತ್ತೆ ನಮಗೆ ವರ್ಕ್ ಡನ್ ಆಗಿದೆ. ಸೊ ವರ್ಕ್ ಡನ್ is stored as the potential energy, so that we have the relation W is equals to mgh, that is the work done against the gravitational force, that is equals to mgh. So this is the work done which is against the gravitational force. So gravitational force is always downwards, right? So this is the work done by the applied force or external force, right? So up to the certain height. So here this is against the gravitational force, hence we taken that one as W is equals to minus mgh, right? So this work done stores as the potential energy at position B, right? So next, considering the another case. So here we taken initially in the vertically height. So ಇಲ್ಲಿ ನಾವು ಏನು ಮಾಡಿದೀವಿ, vertically height ಅಲ್ಲಿ ನಾವು path ನ choose ಮಾಡ್ಕೊಂಡಿದೀವಿ, right? So in this direction. So now we can choose some other path. So again considering the same object of mass m initially on the ground, right, or on the surface. So we call that one as the position A, right? So now I am applying some force to lift the object. So this point is C, right? So we taken this height as h1, right? Now I am displacing this object from C to position D, right? Now from D to E, again from E to A. right? So considering the same height, so initial case 1 ಅಲ್ಲಿ ನಾವು ಎಷ್ಟು height ಗೆ ತಗೊಂಡಿದ್ವು, in the case B also, this is B, right? So ಇಲ್ಲಿ ಕೂಡ ಎಷ್ಟಿರುತ್ತೆ ನಮಗೆ ಸೇಮ್ height h ಅಲ್ಲಿ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ, right? So this height h1, so I am lifting the object from B to E, so this height is h2, right? So again we can write h is equals to h1 plus h2, that is the total height between the points A and B is equals to h1 plus h2, or we can write that one as the h. ಇಲ್ಲಿ ನಮಗೆ only one path ಇದೆ, that is we taken vertically upward. So here first I have taken from A to C, and then from displacing the object from C to D, again from D to E and E to B. So compare ಮಾಡಿದ್ರೆ A ಇಂದ B ವರೆಗೂ ನಾನು ಒಂದೇ ಸಲ ಈ ತರ ಸ್ಟ್ರೈಟ್ ತಗೊಂಡು ಹೋಗಿದ್ದೀನಿ, but here in the second case I have taken the object A from, that is object of mass M, taken from position A to position C up to a certain height h1. Adestadru irbodu, we consider that height as h1, right? So next I am displacing the to D, so that means parallel again ಮಾಡ್ತಾ ಇದೀನಿ ಮತ್ತೆ displace ಮಾಡ್ತಾ ಇದೀನಿ again from D to E, so that height is h2, right? So again from E to B, right? So vertically upward along horizontal, again vertically, again horizontal, right? So here the path followed is A to C, C to D, D to E, again D to B, right? So here directly from A to B, so here from A to B it travels from A to C, then C to D, D to E and E to B, right? So first we are going to calculate the work done. We are bringing from A to C, right? So work done WAC, right? So WAC is the work done, so that is equals to mass and height h1, right? So WAC is equals to mg h1, right? Next, work done from C to D. So C to D we don't have any height, so horizontal displace ಆಗಿರೋದ್ರಿಂದ ಇಲ್ಲಿ ಯಾವುದೇ ತರಹದ height ಇರೋಲ್ಲ, so height ಏನಾಗುತ್ತೆ ನಮಗೆ 0 ಇರುತ್ತೆ, right? So mg into 0, that is equals to 0. So there is no work done while bringing the object from C to D. So horizontal displacement ಅಲ್ಲಿ ನಮಗೆ ಏನಿರುತ್ತೆ, work done 0 ಇರುತ್ತೆ, right? So again from work done from D to E. So again object having the same mass m and it displaces the height h2, right? So mg h2, right? So again bringing the object from E to B, so object ಏನಾಗ್ತಿದೆ ಮೂವ್ ಆಗ್ತಾ ಇದೆ, so force ಇರುತ್ತೆ but ಏನಿಲ್ಲ ನಮಗೆ height ಇರಲ್ಲ. So here we are going to discuss about the gravitational work, that is known as the potential energy. So here also we don't have any height, that is from E to B, so that is mg into 0, that is equals to 0, right? So work done in bringing from A to B, that is the total work done, W A to B, that is equals to WAC plus WCD plus WDE plus WED. So this is the work done from the position A to C, C to D, D to E, then E to B, right? So WAC is how much, that is mg h1, WCD is 0 plus mg h2 again plus 0. So we get mg h1 plus mg h2. So in this 2 we can take mg as common, h1 plus h2. So h1 plus h2 we can directly write h, right? So that is equals to mg h. So this is the work done in bringing the object from A to B, right? So comparing these two relations, right? So ಇಲ್ಲಿ ನಮಗೆ initially from directly A to B ಏನಿದೆ, we get the work done, that is mgh. So path change ಆದರೂ ಕೂಡ ನಮಗೆ work done ಏನು ಬರ್ತಿದೆ finally, that is mgh, right? So from this we can say it is independent of the path followed, right? So from this we can conclude, so work done by the gravitational force is independent of the path followed, so it is depends on the initial position of the object and to the final position of the object. So in the initial position A ಇದೆ, final position B ಇದೆ. So in between these two, so ಏನ್ ವರ್ಕ್ ಆಗುತ್ತೋ so that is always remains the same. So ನಾವು ಯಾವ ಪಾತ್ ಅಲ್ಲಿ ಬೇಕಾದ್ರೂ ತಗೊಂಡು ಹೋಗಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ್ರು ಕೂಡ ನಮಗೆ ವರ್ಕ್ ಡನ್ ಏನಿರುತ್ತೆ ಸೇಮ್ ಇರುತ್ತೆ, right? So this one is the proof for the statement that is conservative force, right? So one more important point about in the conservative force is work done by the conservative force around a closed path is zero. So this is the second condition for the conservative force. So second condition for the conservative force is work done by the conservative force. So those conservative forces example ಏನಿದೆ ನಮಗೆ gravitational force ಇದೆ ಅಥವಾ electrostatic force. So electrostatic force study ಮಾಡ್ತಿಲ್ಲ, only the gravitational force ಅನ್ನು ನಾವು study ಮಾಡ್ತಿರೋದ್ರಿಂದ any force which depends on the initial and final position of the object. So ಅಂತ ಕೇಸಲ್ಲಿ work done ಆಯ್ತು ಅಂದ್ರೆ ಅದನ್ನ conservative force ಅಂತ ಕರೀತೀವಿ. So work done by the conservative force or work done by the gravitational force around the closed path is zero. So ಇದು ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್. So around the closed path ನಮಗೆ ಯಾವಾಗಲೂ ಏನಿರುತ್ತೆ work done ಏನಿರುತ್ತೆ ನಮಗೆ zero ಇರುತ್ತೆ, right? So for this we have the proof. So consider an object of mass m initially at the point A. So on the ground. So ground ಮೇಲೆ object A ಇದೆ. So I am applying some force to lift the object and it displaces to the certain height h. Right? So that position is B. Right? So ನಾನು force apply ಮಾಡ್ತಾ ಇದ್ದೀನಿ. Force apply ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ, object ಏನಾಗುತ್ತೆ displace ಆಗುತ್ತೆ, that is vertically upwards. So ಇಲ್ಲಿ ಏನು ನಾವು vertically upwards ನ ಯಾವಾಗಲೂ ಕನ್ಸಿಡರ್ ಮಾಡ್ತಿದೀವಿ ಅಂದ್ರೆ, so here we are considering the example for the gravitational force. So vertically upwards ಇದೆ ಅಂದ್ರೆ, so this force is against the gravitational force. So work done by the force or against the gravitational force. So ಅಂತದನ್ನ ನಾವು conservative force ಅಂತ ಕರೆಯೋದ್ರಿಂದ, so vertically upward na ನಾವು consider ಮಾಡ್ತೀವಿ, right? So vertically I am applying some force, so object is displaces to the certain height h. So here at the position B the object stores as the work done stores as the potential energy, right? So here work done W is equals to minus mg h. So this is against the gravitational force, right? So at position B ಅಲ್ಲಿ ನಮಗೆ work done ಏನಿರುತ್ತೆ, so this work done stores as the potential energy and the value is mgh, right? So next I am leaving the object. So ಇಲ್ಲಿಂದ first ಏನು ಮಾಡ್ತಾ ಇದ್ದೀನಿ, lift to the B, right? So that is the work done from A to B, that is equals to minus mgh. So ಆಮೇಲೆ ಏನು ಮಾಡ್ತಾ ಇದ್ದೀನಿ, I am leaving this object freely, right? So freely means it will travel with freely falling body. So ಇದೇನಾಗುತ್ತೆ, it will travel in the downward direction. So here the force by the gravitational. So ಇಲ್ಲೇನಾಗ್ತಿದೆ, force due to the gravity force downward act ಆಗ್ತಿರುತ್ತೆ, object displace ಆಗೋದು ಕೂಡ downward direction ಅಲ್ಲಿ. So when it reaches the ground, so here also it stores as the potential energy. So here work done W is equals to mgh. Why here positive means the force, gravitational force is vertically acting downward direction and also displacement in the downward direction. Both are in the same direction, hence we are getting the work done positive. So here work done is negative because the force due to gravity is acting downward direction and displacement is vertically upward direction, right? So hence here we are getting minus mgh. So when it travels from B to A, so initially from A to B and from B to A, so while it travels from B to A, the force due to gravity and the displacement both are in the same direction, hence we are getting the positive work done. So that work done we call as WBA, that is equals to mgh, right? So around a closed path means one complete cycle. So from A to B and from B to A, ಇದನ್ನ ನಾವು ಏನಂತ ಕರೀತೀವಿ, one complete round path ಅಥವಾ circular path ಅಥವಾ closed path ಅಂತ ಕರೀತೀವಿ, right? ಸೊ ಎ ಇಂದ ಬಿ ಹೋಗಿದೆ, ನೆಕ್ಸ್ಟ್ ಬಿ ಇಂದ ಮತ್ತೆ ಎ ಗೆ ಬಂದಿದೆ, ರೈಟ್. ಸೊ ವರ್ಕ್ ಡನ್, ಟೋಟಲ್ ವರ್ಕ್ ಡನ್ W is equals to WAB plus WBA, right? So minus mgh plus mgh, so we get work done W is equals to 0. This is for the closed path. Complete one path na cover ಮಾಡಿದ್ರೆ so ಅಂತ ಕಡೆಗೆ ನಮಗೆ always work done ಏನಿರುತ್ತೆ 0 ಇರುತ್ತೆ. So another example, so here we have sun means so planet is revolving around the sun, right? So here also gravitational force is acting by the sun on the planet, so planet is revolving around the sun. So here work done by the planet always equals to 0, because here it follows the closed path. So initial position elirutte, after certain time it will reach us to the same point. So initial point and the final point eradu same agodinda aduna ನಾವು ಏನಂತ ಕರೀತೀವಿ, closed path ಅಂತ ಕರೀತೀವಿ. So closed path ಅಲ್ಲಿ work done ಏನಿರುತ್ತೆ ನಮಗೆ 0 ಇರುತ್ತೆ. So electrons revolving around the nucleus ಅಲ್ಲಿ ಕೂಡ ನಮಗೆ work done ಏನಿರುತ್ತೆ 0 ಇರುತ್ತೆ, because it is revolving around the nucleus. Similar here the planets which are revolving around the sun, right? The conservative force, so this one is the second condition, right? So due to the conservative force around the closed path ಏನಿರುತ್ತೆ ನಮಗೆ 0 ಇರುತ್ತೆ, right? So next non conservative force. So conservative force ಗೆ opposite ಏನಿರುತ್ತೆ ಅದು non conservative force, right? So if the amount of work done against the force, so ಇಲ್ಲಿ by the force ಇರಲ್ಲ, so ಇಲ್ಲಿ ಯಾವಾಗಲೂ ಏನಿರುತ್ತೆ ನಮಗೆ against the force depends on path followed by the objects or by the particle. So ಇದನ್ನ ನಾವು ಏನಂತ ಕರೀತೀವಿ, non conservative force. So non conservative force ಅಲ್ಲಿ initial ಮತ್ತೆ final position ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿರಲ್ಲ, it completely depends on the path. ಅದು ಯಾವ path ಅಲ್ಲಿ travel ಆಗ್ತಾ ಇದೆ ಅಂತದನ್ನ ನಾವೇನಂತ ಕರೀತೀವಿ, non conservative force. That type of forces we call as the non conservative forces, right? So here the force, that is amount of work done, ಇಲ್ಲಿ ಎರಡು ಕೇಸಸ್ ಇತ್ತು, by the force or against the force. So ಇಲ್ಲಿ by the force ಇರಲ್ಲ, only against the force, right? So ಈಗ ನಾನು ಯಾವುದಾದ್ರೂ ಒಂದು ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡ್ತಾ ಇದ್ದೀನಿ ಆಬ್ಜೆಕ್ಟ್ ಮೇಲೆ ಅಂದ್ರೆ, so there is against force nothing but the frictional force. So work done by the frictional force is always the non conservative force, right? So example, friction and viscous force. So viscous force ನಾವು fluids ಅಲ್ಲಿ ಸ್ಟಡಿ ಮಾಡ್ತೀವಿ. So in mechanics ಅಲ್ಲಿ friction. So friction is the non conservative force, right? So ಇಲ್ಲಿ ನಮಗೆ ಸೆಕೆಂಡ್ ಕೇಸ್ ಅಥವಾ ಸೆಕೆಂಡ್ ಕಂಡೀಷನ್ ಇರೋದಿಲ್ಲ. So the example, and consider an object which is placing on the surface. So apply some external force F. So there is a contact force arises between the object and to the surface. So that we call as the frictional force, Fs or Fk. So force apply ಆಗ್ತಾ ಇದೆ. So here the object also displaced. So object ಏನಾಗುತ್ತೆ ನಮಗೆ change ಆಗುತ್ತೆ. So x side to the xf. So ಇದು initial position ಆದ್ರೆ ಇದು final position ಆಗುತ್ತೆ. So here work done by the frictional force. So aduna ಹೇಳ್ತಾ ಇರೋದು amount of work done against the force. So against the force ಅಂದ್ರೆ ಇಲ್ಲಿ F is the force which we applied. So against to this force is the frictional force, that is Fs, right? So force ಇದೆ, ಜೊತೆಗೆ ಆಬ್ಜೆಕ್ಟ್ ಕೂಡ ಏನಾಗಿದೆ ನಮಗೆ ಡಿಸ್ಪ್ಲೇಸ್ ಆಗಿದೆ. So here in this case it depends on the path followed. So ಅದು ಯಾವ ಪಾತ್ ಅಲ್ಲಿ ಆಬ್ಜೆಕ್ಟ್ ಮೂವ್ ಆಗ್ತಿದೆ ಅನ್ನೋದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿರುತ್ತೆ. So that is the friction. So friction force or viscous force depends on the path followed, right? So this is about the conservative force and non conservative force. So ತುಂಬಾ ಇಂಪಾರ್ಟೆನ್ಸ್ ಇರೋದು conservative force. So examples ಯಾವ್ಯಾವ್ದು ಇದೆ ಅಂದ್ರೆ gravitational force ಮತ್ತೆ electrostatic force. So electrostatic force second year ಅಲ್ಲಿ ಸ್ಟಡಿ ಮಾಡೋದ್ರಿಂದ gravitational force ಅಂತೂ ನೆನಪಲ್ಲಿ ಇರಲೇಬೇಕು, right? So next, conservation of mechanical energy. So very important for 5 marks. So ತುಂಬಾ ಸಲ 5 marks ಗೆ derivation ಕೇಳಿದ್ದಾರೆ. That is conservation of mechanical energy in case of freely falling object. So freely falling body na example itkonbitu we need to derive the conservation of the mechanical energy. So mechanical energy is nothing but sum of the kinetic energy and potential energy, right? So sum of kinetic energy and potential energy always remains constant, right? So this one is the statement for the conservation of the mechanical energy. So mechanical energy andre we have the kinetic energy and potential energy. So sum of the kinetic energy and potential always remains same means or constant means that is sum of kinetic energy plus potential energy that is equals to some constant. So ನಾವು ಯಾವುದೇ ಕೇಸ್ ಅಲ್ಲಿ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರು ಕೂಡ ಕನ್ಸರ್ವೇಟಿವ್ ಫೋರ್ಸಸ್ ಇರಬಹುದು, ರೈಟ್? ಸೊ ಇದು ಆಲ್ಮೋಸ್ಟ್ ನಮಗೆ ಕನ್ಸರ್ವೇಷನ್ ಆಫ್ ಮೆಕ್ಯಾನಿಕಲ್ ಎನರ್ಜಿ ಅಂದ್ರೆ ಕನ್ಸರ್ವೇಟಿವ್ ಫೋರ್ಸಸ್ ನ ಇಟ್ಕೊಂಡು ಎಕ್ಸಾಂಪಲ್ ಅಲ್ಲಿ ನಾವು ಪ್ರೂವ್ ಮಾಡಿದ್ರೆ ಮಾತ್ರ ನಮಗೆ ಏನ್ ಸಿಗುತ್ತೆ, ಕನ್ಸರ್ವೇಷನ್ ಆಫ್ ಮೆಕ್ಯಾನಿಕಲ್ ಎನರ್ಜಿ ಸಿಗುತ್ತೆ, ರೈಟ್? ಸೊ ಇನ್ ದಟ್ ಕೇಸ್ kinetic energy and potential energy of the object is always remains constant. So this is the statement for the conservation of mechanical energy, right? So for the proof, so 5 marks is very important, right? So consider an object of mass m, so initially at a height h from the ground. So this is the ground. Considered an object having mass m initially at a certain height h. So object ka consider ಮಾಡಿದೀವಿ, object ಗೆ ನಮಗೆ ಏನಿದೆ, mass ಇದೆ. So initially the object is at rest, that means its initial velocity u is 0, right? So object certain height ಅಲ್ಲಿ ಕನ್ಸಿಡರ್ ಮಾಡಿದೀವಿ. So ಅದರ ಇನಿಷಿಯಲ್ ರೆಸ್ಟ್ ಅಲ್ಲಿ ಇದೆ. So ರೆಸ್ಟ್ ಅಲ್ಲಿ ಇದೆ ಅಂದ್ರೆ ಆಬ್ಜೆಕ್ಟ್ ಇನಿಷಿಯಲ್ ವೆಲಾಸಿಟಿ ಏನಿರುತ್ತೆ ನಮಗೆ 0 ಇರುತ್ತೆ, right? So for this case considering or choosing the points A, right? So at point A, right? So initially rest ಅಲ್ಲಿ ಇದೆ. So rest ಅಲ್ಲಿ ಇರೋದ್ರಿಂದ there is no kinetic energy at point A or at position A, right? Kinetic energy that is equals to 0. Next, at the point A, potential energy right? So potential energy it is certain height from the ground. So here on this object gravitational force is acting, so work done by the gravitational force stores as the potential energy, right? So potential energy at point A we can write that one as mgh. So where g is the acceleration due to gravity, m is the mass of the object and h is the height of the object. So we are going to prove for the conservation of mechanical energy. So sum of kinetic energy plus potential energy, so that gives for the kinetic energy, right? So kinetic energy plus potential energy, right, that is equals to, or we can write this one as total energy. Mechanical energy, we will write. Mechanical energy is equals to sum of the kinetic energy plus potential energy, right? That is equals to kinetic energy is 0 plus potential energy is mgh. So finally we get mgh, calling this one as first equation, right? So first consider one object having some mass. So initially the object is at rest at a certain height h. So rest ಅಲ್ಲಿ ಇದೆ ಅಂದ್ರೆ its initial velocity is 0. So 0 ಇದೆ ಅಂದ್ರೆ kinetic energy ಏನಿರುತ್ತೆ ನಮಗೆ 0 ಇರುತ್ತೆ. But the potential energy work done by the gravitational force, so that stores as the potential energy and the value is mgh. So mechanical energy is equals to kinetic energy plus potential energy. So kinetic energy is 0, potential energy is mgh, mechanical energy we are getting mgh. Calling, we taken this one as the equation 1, right? So now we left this object to freely fall. So ಈಗ ಏನು ಮಾಡ್ತಾ ಇದೀವಿ, ಈ object ನ free fall ಆಗಿ ಬಿಡ್ತಾ ಇದೀವಿ. So at after certain time t, the object will reaches some distance. That means it covers some distance. So next time ಮಾಡ್ತಾ ಇದೀವಿ object ನ ಲೀವ್ ಮಾಡ್ತಿದೀವಿ. That means freely fall ಮಾಡೋದು ಬಿಟ್ಟಾಗ ಈ ಆಬ್ಜೆಕ್ಟ್ ಏನಾಗುತ್ತೆ, it starts to move. So as the object starts to move, it changes its velocity. So 0 ಇರೋದು ಏನಾಗುತ್ತೆ, it gains some velocity. We taken that velocity as v1, right? So it covers some distance. So our distance ಎಷ್ಟಿದೆ ಅಂತ ನಮಗೆ ಗೊತ್ತಿಲ್ಲ. We taken that distance as x. X is the distance covered by the object after certain time t and reaches the position b, right? So ಇಲ್ಲಿ ನಮಗೆ ಟೋಟಲ್ ಹೈಟ್ h ಇದೆ. So from the top ಇಂದ ಎಷ್ಟು ಕವರ್ ಮಾಡ್ತಿದೆ, x ಕವರ್ ಮಾಡ್ತಿದೆ. ಅದೇ from the bottom or from the ground the height is h minus x, right? Now at point b, right? So at point b ಅಲ್ಲಿ ನಾವು ಆಬ್ಜೆಕ್ಟ್ ನ ಫ್ರೀ ಫಾಲ್ ಆಗಿ ಬಿಡ್ತಾ ಇದೀವಿ ಅಂದ್ರೆ ಆಬ್ಜೆಕ್ಟ್ will starts to move in the downward direction, right? So ಈ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಮೂವ್ ಆಗಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಗ್ತಿದೆ. ಮೂವ್ ಆಗ್ತಿದೆ ಅಂದ್ರೆ that means it has some velocity. So we take up that velocity as v1, right? So certain choose ಮಾಡ್ಕೊಂಡಿದೀವಿ position x in between the ground and to the initial position a. So ಎಷ್ಟು ಡಿಸ್ಟೆನ್ಸ್ ಇಂದ ಗೊತ್ತಿಲ್ಲ. So we taken that one as x, right? So now we are going to calculate the kinetic energy and potential energy of the object at point b, right? So for this at point b, kinetic energy, we have the formula half m v1 square, right? So kinetic energy ke formula na derive ಮಾಡ್ಕೊಂಡಿದ್ವಿ, that is half m v1 square, right? So we need to find the value of v1. So here vertically downward motion, from the equations of motion we can find the value of v1 square, right? So from equations of motion, v1 square, that is v square minus u square, that is equals to 2as. So e relation na use ಮಾಡ್ಕೊಂಡು we are going to find the value of v1. So here v1 is the final velocity, u is the initial velocity. So initial velocity is 0 and the final velocity is v1. So it covers the displacement x. So vertically downward ಇರೋದ್ರಿಂದ g value ಏನಿರುತ್ತೆ ನಮಗೆ ಪಾಸಿಟಿವ್ ಇರುತ್ತೆ. So v1 square minus 0, that is equals to 2gx, right? So v1 square minus 0, v1 square. So v1 square value is 2gx. So substitute v1 value to the kinetic energy, right? Kinetic energy, that is equals to half m. So in place of v1 square you can substitute 2gx. So 2 get cancels. So kinetic energy value is getting mgx, right? So this is the kinetic energy. Next, at the same point b, we are going to find the potential energy, right? Potential energy at point b. So here also due to the gravity, the object is falling freely. So gravitational force ಯಾವ ಕಡೆಗೆ ಆಗ್ತಿದೆ, always vertically downward act ಆಗ್ತಿದೆ. So displace ಆಗ್ತಿರೋದು ಕೂಡ vertically downwards. So this potential energy we taken mgh. So h ಎಷ್ಟಿದೆ, h minus x, that is from the ground in the s right ಅಲ್ಲಿ ಇದೆ, ಅದನ್ನ ನಾವೇನಂತ ಬರ್ಕೊಳ್ತೀವಿ, mgh minus x. So potential energy is mgh minus x, right? So here we need to find the mechanical energy, right? So mechanical energy is equals to kinetic energy plus potential energy. Potential energy. So here so kinetic energy value ಏನಿದೆ ನಮಗೆ, mgx plus potential energy value mgh minus x, right? So now simplifying this value, so mechanical energy that is equals to mgx plus mgh minus mgx, right? So ಇದನ್ನ inside multiply ಮಾಡಿದ್ರೆ mgh minus mgx, right? So mgh plus mgx minus mgx get cancels, so we get mechanical energy is equals to mgh. So calling this one as second equation. So ಇಲ್ಲಿಗೆ ನಿಮಗೆ ಅರ್ಥ ಆಗಿರುತ್ತೆ ಮೆಕ್ಯಾನಿಕಲ್ ಎನರ್ಜಿ ಅಟ್ ಪಾಯಿಂಟ್ ಎ ಏನಿದೆ ನಮಗೆ mgh ಇದೆ, ಮೆಕ್ಯಾನಿಕಲ್ ಎನರ್ಜಿ ಅಟ್ ಪಾಯಿಂಟ್ ಬಿ ಕೂಡ ಏನಿದೆ ನಮಗೆ mgh ಇದೆ, right? So that means mechanical energy at every point remains the same, right? So first case ಅಲ್ಲಿ ನಮಗೆ ವ್ಯಾಲ್ಯೂ ಏನು ಬಂದಿತ್ತು, mgh. So m constant, g constant, height ಕೂಡ ಏನಿದೆ ನಮಗೆ ಕಾನ್ಸ್ಟೆಂಟ್ ಇದೆ. That means sum of the kinetic energy and potential energy is always equals to the constant, right? So a case ಆಯ್ತು, b ಆಯ್ತು, right? So next when it reaches the ground, right, we taken that point as point c. So just before reaches to the ground ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರು, ಇಲ್ಲಿ ನಮಗೆ ವೆಲಾಸಿಟಿ ಏನಿರುತ್ತೆ, v2. So same object when it reaches the ground, just before reaching the ground its velocity is v2 and here is no height. So ಇಲ್ಲಿ ನಮಗೆ ಏನಿರಲ್ಲ, height ಇರೋದಿಲ್ಲ, right? So next at point c, right? So at point c kinetic energy is equals to half m v2 square. So ಇಲ್ಲಿ ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ದು v1 velocity, so ಇಲ್ಲಿಗೆ ಬರ್ತಾ ಇದ್ರೆ v2 velocity ಇದೆ, right? So kinetic energy relation ಏನಾಯ್ತು, half m v2 square, right? So we need to find the v2 square value again from the equations of motion by using the same relation, v square minus m square is equals to 2as. So v square in place of we need to substitute v2 square, again its initial velocity is 0 and it covers the distance from a to c, that means h. So displacement ಎಷ್ಟಿರುತ್ತೆ ನಮಗೆ, h ಇರುತ್ತೆ, right? So v2 square minus 0 that is equals to 2gh, because so initially it travel from a and it reaches to c, so its initial velocity is 0, so it covers the displacement h, so its velocity is v2, right? So v2 square is equals to 2gh. So substituting to the kinetic energy, half m 2gh. So 2 get cancels, we get mgh. So kinetic energy is mgh, right? So next potential energy. Potential energy we have the formula mgh. So ಇಲ್ಲಿ ನಮಗೆ ಯಾವುದೇ height ಇಲ್ಲ, between the ground and to the object there is no height, that means h is 0, right? So mg into 0, height is 0, right? So here you can write h is equals to 0. When its height is 0, potential energy is 0. For this case mechanical energy, right, I will write here mechanical energy. So mechanical energy is sum of kinetic energy plus potential energy. So kinetic energy we get it mgh plus potential energy is 0. Again we get mgh. Calling this one as equation 3. Right. So now observe or compare the mechanical energy at each point. Right. So mechanical energy at point A is mgh. Mechanical energy at point B is mgh, and the mechanical energy at point C is mgh. Right? So from this we can conclude that potential energy and kinetic energy, that is sum of kinetic energy and potential energy, always remains constant. So this is in the case of freely falling body. Right? So this is when freely falling object or freely falling body. So this only in the case we can prove that. So the force is conservative. Conservative force alli ಮಾತ್ರ ನಾವು ಇದನ್ನ ಪ್ರೂವ್ ಮಾಡಬಹುದು. So conservative force is again the gravitational force. So ಇಲ್ಲಿ ನಮಗೆ ಯಾವ force act ಆಗ್ತಾ ಇದೆ? Work done by the gravitational force, right? So that's why the sum of kinetic energy and potential energy is always remains the same or constant. So idu namge proof. So 5 marks ge tumba important. So lengthy derivation but simple concept ide. So tumba sala repeat agide. So just we need to find the considering 3 cases, and we need to find the kinetic energy and potential energy at each point. So we need to add those kinetic energy and potential energy. That means we are going to find the mechanical energy, right? So mechanical energy at A, mechanical energy at B, and mechanical energy at C. So at each point the mechanical energy remains the same. Then we can conclude that the sum of kinetic energy and potential energy remains the same, right? So namge values different bantu andre change agta irtade, right? So idralli innondu observe ಮಾಡಬೇಕು ಅಂದ್ರೆ initially the kinetic energy 0 irutte, potential energy maximum value irutte, right? So as it moves vertically downwards, so vertically down move ಆಗ್ತಾ ಇದ್ದಂಗೆ kinetic energy increase ಆಗ್ತಾ ಹೋಗುತ್ತೆ, potential energy decrease ಆಗ್ತಾ ಹೋಗುತ್ತೆ. So in the second case you can observe here, so kinetic energy we getting mgx, and potential energy we are getting mgh minus x. That means some value is lessing. So initially mgh is the potential energy at A, but at B we have the potential energy mgh minus x, right? So initially some height 10 ಇದೆ ಅಂದ್ರೆ, so x ಅಂದ್ರೆ some 5 ಅಷ್ಟು ಕವರ್ ಆಗಿದೆ ಅಂದ್ರೆ initially potential energy at A ಎಷ್ಟಿರುತ್ತೆ? mg h value is 10 mg irutte, right? Mass into g. So ಅದೇ certain distance cover ಮಾಡಿದ್ಮೇಲೆ distance ಕಮ್ಮಿ ಆಗ್ತಿದೆ, ಎಷ್ಟು ಕಮ್ಮಿ ಆಗಿದೆ? 5 ಕಮ್ಮಿ ಆಗಿದೆ ಅಂದ್ರೆ ಇಲ್ಲಿ ಎಷ್ಟಿರುತ್ತೆ? 5 mg. So 10 is greater than 5, so that means the potential energy is decreasing and kinetic energy ಏನಾಗ್ತಿದೆ? increase ಆಗ್ತಿದೆ. So initially kinetic energy ಏನಿರುತ್ತೆ ನಮಗೆ 0 ಇರುತ್ತೆ. So as it covers the distances, so it gains some kinetic energy, so that value is mgx, right? And when it reaches to the ground, so here total we have the kinetic energy but the potential energy is 0. So point A ಅಲ್ಲಿ kinetic energy 0 ಇರುತ್ತೆ, point C ಅಲ್ಲಿ ನಮಗೆ potential energy 0 ಇರುತ್ತೆ, right? So A ಅಲ್ಲಿ kinetic energy 0 ಇರುತ್ತೆ, C ಅಲ್ಲಿ potential energy 0 ಇರುತ್ತೆ. So ಇಲ್ಲಿ ನಮಗೆ potential energy maximum ಇರುತ್ತೆ, so ಇಲ್ಲಿ ನಮಗೆ kinetic energy maximum ಇರುತ್ತೆ. So kinetic energy, potential energy values vary ಆಗ್ತಿದೆ, but sum of these two always remains constant. That means mechanical energy ಏನಿರುತ್ತೆ ನಮಗೆ always constant ಇರುತ್ತೆ, that is remains same ಇರುತ್ತೆ. So ತುಂಬಾ important, you need to practice. So ನೀವು practice ಮಾಡ್ದಲೇ ಇದ್ರೆ ತುಂಬಾ confusions ಆಗುತ್ತೆ. So simplification mainly ಇರೋದು simplification. So simplification miss ಆಯ್ತು ಅಂದ್ರೆ you can't conclude the 3 cases. So first, second, at point A, point B and point C ಅಲ್ಲಿ mgh value ಬರಬೇಕು, right? ಬರಬೇಕು ಅಂತ ಮತ್ತೆ ನಿಮ್ಮ own simplification ಮಾಡಿದ್ರೆ ಮತ್ತೆ ರಾಂಗ್ ಆಗುತ್ತೆ, right? So practice ಮಾಡಿ, ತುಂಬಾ ಸಲ ರಿಪೀಟ್ ಆಗಿರೋ ಕ್ವೆಶ್ಚನ್ಸ್, ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್ ಕ್ವೆಶ್ಚನ್, right? So ಕಾನ್ಸೆಪ್ಟ್ ಗೊತ್ತಿರಲಿ ಅಷ್ಟೇ. ಸೊ ನಿಮ್ಗೆ ಐಡಿಯಾ ಇತ್ತು ಅಂದ್ರೆ ಓನ್ ಆಗಿ ಕೂಡ ನೀವು ಸಿಂಪ್ಲಿಫೈ ಮಾಡಬಹುದು, right? So remaining power. So this is all about the energy. So next class ಅಲ್ಲಿ power ಇದೆ. So ಸ್ವಲ್ಪ ಇರೋದ್ರಿಂದ ಪವರ್ ಆದ್ಮೇಲೆ collisions ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್ ಇದೆ collisions ಕೂಡ. We will continue in our next class. Thank you.